let's take a look at some more probability questions. So in this case, we have been given a board game. Let's imagine that this square or rectangle shape is a board game, and then this blue color circle represents a region inside the board game. Now we are going to roll a dice. When we roll the dice, we want to find out the probability that the dice will actually fall inside the circular region. So what is the probability when we roll this dice that the dice will fall inside the circular region? And obviously when you have questions like these, all of the dimensions will be given to you. That means the length, the breadth, and the diameter or the radius of this circle, they will be given. And now this doesn't have to be really a circle. It can be a triangle, it can be a rectangle, or it can be any region. So the idea here is that how do we calculate probability in a question like this where we have sort of geometry meeting probability. So let's find out how we answer these questions. Now when we actually roll the dice can fall here, let's say, or the dice can fall here, or the dice can fall here, dice can roll in here, 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 here. So you get the point. Whenever we roll the dice literally can fall anywhere on the game board, right? Including inside the circular region. Now, when we calculate probability, we have seen that probability of any event is the number of outcomes favorable to the event divided by total number of outcomes. So here, probability of our event is dice falling inside the circular region. So that means we have to find out all possible outcomes. Let's give ourselves a little bit more space here. We have to find out number of all outcomes favorable to the dice rolling inside the circular region here, right? And we have to divide that by the total number of outcomes where the dice may actually fall. In other words, what we are really trying to do here is that we are trying to find out all possible outcomes that capture the dice falling inside of this circular region. So dice can fall here, 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 anywhere inside the circle. So we have to find out a way to capture the all outcomes of the dice falling inside of this circle, right? It can be anywhere inside our circle. So how do we actually find that out? So the way we find that out simply is that we find out the area highlighted in blue of the circle. So this is very, very, very important for you to conceptually understand that the numerator, where we are trying to find out number of outcomes favorable to the dice rolling inside circle, because the dice can be anywhere inside the circle, the way we capture all of the outcomes that are favorable to the dice falling inside the circle is by calculating the area of the entire circle. Because when we calculate the area of any shape, it gives us the entire amount of region covered inside the space. So the area gives us all outcomes favorable to dice rolling inside the circle, the numerator. Now let's go back to the fact that the dice itself can fall anywhere inside of the board game, right? In other words, this yellow shaded space area, now that gives us the denominator. So the total number of outcomes where the dice may fall, because the dice can fall anywhere on the game board, including the circular area, the dice can fall anywhere within the game board. To capture all possible outcomes, we have to find out the area of the game board. So in other words, in this particular case, or in these examples, the way we solve these examples is that we simply find out the area. So like I said before, the measurements will be given. So the length will be given, let's say to us, this length over here, and this breadth will be given, or the width. So these will be given, and similarly for the circle, or now this doesn't have to be a circle, but in this case if it is a circle, the radius will be given. So the way we calculate these questions, we find out this probability simply. We find out the area, in this case the area, I should say area of, let's give ourselves just a little bit more space here, area of the circle, and we divide that by area of the board game, or area of the board, or the area of the rectangle basically, and that gives us the probability. Now before we wrap this up, one other quick point. If the question were to ask us, find the probability when we roll the dice does not fall inside the circular region, how will we solve that question? Remember very quickly, we have discussed this before. If E is an event, the dice falls inside the circular region, then we can say E dash or E bar represents the event, dice never falls inside the circular region, right? And now we have also seen that probability, we call them complementary events. So the probability of the event plus probability of the complementary event, they always add up to 1. So let's say we calculate the probability of the event dice falling inside the circular region, and let's say when we actually find out this calculation, let's just say that we get the number point, maybe say 32. I'm just making this randomly up. So then we can have this plus this equal to 1, or we can say that probability of this complementary event, and what is E dash? That the dice never falls inside the circular region. So that will be simply this, or this will be 0. I believe 68. So this is how we solve these questions where we have geometry mixing up with probability.